This class we are going to see about some more of the 8085 instruction sets, and then of course we have already seen few instruction sets, and in this class we are going to see about branch and machine control instructions, and then the addressing modes of 8085, and we are also going to see about see few examples how to program the microcontroller with a few examples we are going to see now. So, in the last class itself we saw that the 8085 instructions can be grouped into 5 categories, namely data transfer instructions, and then the instructions for arithmetic operation, and instructions for logic operations, then instructions for branch operations, and machine control operation instructions. So, we have seen the data transfer, arithmetic operation instruction and logic operation instructions in the last class, and this class we will see about the branch instructions. So, branch operations. Okay. So, the branch operation or these branch instructions are meant to control the flow of the program. Okay. So, the program starts from a memory location and it proceeds sequentially. So, 1, 2, so memory location, suppose it starts from memory location number 0, it proceeds in a sequential order 0, 1, 2, 3, 4, 5, 6, etc. So, the program will be stored in a sequential manner from one memory, next memory, and so on, memory location and so on. Suppose you want to jump from a particular location to jump to the program which is stored in some other location, then you have to use the jump instruction. So, the program, instead of proceeding in this manner, so it can proceed like this, and then immediately it can jump to some other memory location and then again proceed. So, for this purpose jump instructions are used. So, they are called as jump instructions. Okay. So, in jump instruction there are two types, that is conditional jump. So, the program will jump from the normal flow to the location pointed out by the jump instruction based on the condition. Okay. Condition means the condition of any operation. So, if you do arithmetic or logic operation, the flag registers will be affected. So, depending upon the conditions that are in the flag register, so the program can be made to jump to any location. Okay. Then you can also simply say jump without any condition. So, the program can go like, when it is going like this, you can simply say jump. So, it will simply jump to some other location, okay, whether it may jump here or maybe there. Okay. So, without any condition. So, that is called as unconditional jump. Then another type of jump that is called as the call and return. So, the call and return jump instructions are used for calling subroutines. Okay. So, subroutines are subprograms that are used frequently. For example, 8085 does not have multiply instructions. Okay. So, if you are doing some arithmetic operation where it involves lot of multiplication, you have to write the multiplication instruction as a separate subprogram. So, that has to be stored in some part of the memory. Okay. So, whenever you want to do multiplication, you can call that program from that part of the memory. So, you have to simply jump to that part of the memory, that is called as calling that say multiplication program. So, once the multiplication is done, so you can to return back to the same location where you have left the main program. So, the returning back to the same location where you have left the main program is called as the return. Okay. So, this is also a jump. This is a different kind of jump where the program jumps to some location and performs another subprogram, and once it completes the subprogram, it returns back. When you give the return instruction, it returns back to the memory location where it has left it previously. Okay. So, that is called as the call and return instruction. Here also we have conditional call and conditional return, and similarly unconditional call and unconditional return. Okay. So, these are the two types of call and return instruction. Okay. So, now let us so the address. So, you have for all the jump and call instruction. So, you have to supply the address where the program has to jump. Okay. So, the programs are stored in memory location. So, 8085 can address 64,000 locations of memory. Therefore, the address consists of 16-bit binary number. So, you have to mention the exact address with a 16-bit number. Okay. That is a 2 bytes to which the program has to jump. So, the jump instruction has to be followed by jump or call instruction has to be followed by a 16 bit digit which represents the address to which the program has to jump. Okay. So, now we will see a few examples of the jump instruction. So, the first example, okay. So, you want to jump to a memory location. So, the location number is of course in hexadecimal format is 208H, H means hexadecimal. So, this is a, and if you have to jump only if the carry flag is set. Okay. So, jump instruction, you have to mention the address where it has to jump, and you have to mention whether it is conditional or unconditional. So, in this case this is a conditional, that is it has to jump to the location number, okay, if the carry flag is set. So, what is the instruction for that? Okay. So, the instruction for that is JC, J means jump, C means carry, and this has to be followed by a 16 bit address. So, this is a 16 bit address represented in a shorthand hexadecimal form. So, 2080H. Okay. Another example we will see. So, let us see unconditional jump. Okay. Simply you have to jump to a specific memory location. Okay. Then in that case JMP, simply jump, JUMP. Okay. So, shorthand form of JUMP is JMP. Okay. So, this is the mnemonics for the jump. Okay. Jump and just mention the address, no conditions. When it encounters this opcode, simply it will jump to this location. So, the opcode for jump has to be followed by this hexadecimal, that is a 16 bit number, okay, which represents the address to which the program has to jump. Then again the call. So, here also this also has to be followed by a 16 bit address. Okay. So, simply you have to call. So, call followed by the 16 bit address, okay, 30550H. So, the program will branch to this location once it encounters this opcode for this call. Okay. And another is of course again coming back. So, the call instruction is always associated with subroutine. So, it will go to a subprogram, and once it has finished the subprogram, it has to return back where it has left the original program. It has to return back to the original program. Okay. So, the microprocessor will remember using the stack pointer, the microprocessor will remember where it has left. Okay. We will see in the coming lectures about the stack pointer and how the microprocessor remembers where it has left the program. Okay. So, once it encounters the return instruction, okay, so it will take the return address which has been already stored in the memory location called as stack, and then it will return back to where it has left the main program. So, that is the return instruction. So, the return instruction and call instruction can also be conditional. For example, you want to call a subroutine if the carry flag is set or maybe reset, then jump no carry. Carry 0 means no carry, no carry means 0 carry. Okay. Carry flag is set, reset, that is carry flag is 0. Jump no carry, C is that is call no carry, C means goes call. Okay. N means no, C means again carry. Okay. 3050H. Okay. Then again a conditional return instruction, return if 0 flag is set. Okay. So, return R correspond to return and Z correspond to 0 flag, return if 0 flag is set. So, there are like that, there are many conditional instructions. I will now list all the conditional instructions. Okay. So, JZ, okay, jump if 0 flag, Z is 0, okay, 0 flag. So, we have flag register where we have 0 flag, carry flag, auxiliary carry flag, sign bit flag and so on. Okay. So, this 0 flag is set, then it has to jump, J jump Z 0, okay, 0 flag is set, the program has to jump. Suppose if the 0 flag is not set, you want to jump means then N means not. If the 0 flag is not set, then the program will jump. Okay. Then carry, you want to jump depending upon the carry flag. So, carry flag is represented as C. Okay. So, it is by I hope it is very easy to remember, Z means 0, C means carry. Okay. So, it will jump to the address if the carry flag is set. Suppose if the carry flag is not set, what is the opcode or what is the mnemonic? So, N not. So, if the carry flag is not set, then the program will jump, JNC. Okay. If the carry flag is not set, if there is no carry flag, then the program will jump. Then again sign flag. Okay. So, the sign flag represent the sign. So, we use the to represent positive and negative number. So, in digital computer cannot it knows only 0 and 1, it does not know plus minus. So, we have to use one binary digit, the most significant bit as the sign bit in signed arithmetic operation. So, if the sign flag is 0, then it is positive. If the sign flag is 1, then it is negative. Okay. So, if the sign flag is set, not set means it is positive. So, P means positive. Okay. Then negative means minus. So, if the sign flag is set, then the number is negative, then M means minus. So, if the sign flag is set, that means the result is negative, then or minus, then the program will jump. Then of course, there are instructions for machine control also. Okay. So, these are some 2 instructions that are used for controlling the hardware operation. Okay. So, the halt means it will simply stop, and no operation means it will not do any work, it will simply skip that instruction without doing any operation. Okay. So, what is the use of this instruction? Call halt means after you have done the job, you want the microprocessor to stop after the program has been finished, then you use halt instruction. Then no operation. So, the microprocessor will simply take the instruction and then go to the next instruction without performing any work. Okay. So, you want to introduce some time delay in the microprocessor. The microprocessor is used for many timing applications. So, you want to use some time delay. So, this instruction can be used for creating some time delay. So, it does not do any work, at the same time it creates some time delay. So, of course, the microprocessor has to take this instruction to the instruction register and decode it, and after decoding it, it will not perform any job. So, that process creates some time delay. Okay. So, although it does not do any work. Okay. So, you can use it for creating time delays in the time delay loop, this no op instruction. Okay. Now, we will see about the various operands. Okay. So, we for writing the program, so we give the command, and then that is the operation, and then the operation has to be performed by an operand. So, we say add, and then what to add. So, the operand has to follow the add instruction. Okay. So, for example, add this instruction, let us say add. So, what to add? It has to be followed by the number that has to be added. So, this is called as operand. Okay. So, sometimes you may not tell the instruction may not follow the operand. So, in this case instruction is followed by operand, but in this case CMA, A means accumulator. So, we are not writing what number to be compared. Okay. So, simply say compare what is the content in the accumulator. Okay. Another register also can be an operand. So, you want to subtract, what to subtract? You have to subtract the contents of the register B. So, the B is the operand. Okay. So, we are seeing about the different types of operands. Okay. So, when you give a instruction, the instructions has to be followed by an operand. Okay. Sometimes of course, the operands are implied. Okay. So, you may not specifically mention the operand. So, in this example you say compare accumulator. So, the contents of the accumulator is operands. We are not exclusively mentioning an operand for this compare instruction. Okay. So, let us take another example. So, add instruction. So, this instruction add immediate. So, the operand which has to, you have to add this, that follows the instruction. Okay. So, instruction opcode for instruction followed by the operand that has to be added. Then the operand may also be contents of a register. Okay. So, the register, so you have to say, so for example, you see here subtract. So, you have to do the subtraction operation. What to subtract? The contents of register B. So, in this case the register. Okay. So, internal register of the 8085 is an operand. Okay. And you can also have a 16-bit operand. For example, you want to do some memory operation involving a memory. So, move the data to a memory location or take data from the memory location, then you have to mention the memory address. Okay. So, this the load accumulator is an instruction. So, this instruction has to be followed by an operand. So, in this case it is a 16-bit number which represents the address of a memory location. So, the 16-bit address represents the memory location. So, the memory address which is 16 bits is an operand. Okay. Now, let us see about the instruction side. So, the instructions we saw. Okay. So, in some instructions may contain operand, some instruction may not contain operand. So, the operand may be a 8 bit or sometimes it can be 16 bit if you want to mention the address of the memory location. So, depending upon the type of the instruction. So, the instructions can be a single byte instruction, or suppose you are mentioning a data immediately, then the instruction can be a 2 byte instruction, or the instruction can be when you are mentioning an address operand plus 2 bytes of address, then the instruction can be a 3 byte instruction also. Okay. So, we have in 8085 we have single byte instruction, 2 byte instruction and 3 byte instruction. Okay. So, as I mentioned, okay. So, there can be single byte, 2 byte and then it can be 3 byte. Okay. So, the instructions corresponding to memory operations where you have to mention the address of the memory locations, they are all involve 16 bit address. Okay. So, the memory has to be represented by a 16 bit number, therefore, they are all 3 byte instructions. For example, okay. So, you want to load an 8 bit number into the accumulator. Okay. Let us see the examples what we saw in the previous slide. We will see with few examples. So, you want to move a data to the accumulator. So, you have the instruction opcode for this instruction move immediate A and followed by the data. So, both put together it is a 2 byte instruction. Okay. So, move immediate A. Okay. So, the machine code for that move immediate A is 3E. So, this is the first byte. Okay. And then this is the data 32. Okay, hexadecimal. So, 0 1 1 is the binary for 3 and then 2, the binary number for 2 is 0 0 1 0. Okay. So, 3 2. So, this is the second byte. Okay. So, move immediate A. So, when it goes inside the microprocessor, it goes as 3E 32. Of course, it will be loaded as 0 0 1 1 1 1 1, that represents 3E, and then this is the opcode for move immediate A, and then the data 32 0 0 1 1 and 0 0 1 0. So, this is the actual machine code that goes into the memory of the microprocessor. Then you want to jump to some address 2085, of course hex. Okay. So, instruction is JMP 2085, of course hex. So, what is the opcode? So, you have to, for jump you have the opcode is C3. Okay. And then this opcode should be followed by this address. Okay. It has to be followed by this address. So, this lower byte, okay, 85 and then higher byte. Okay. When it goes inside the memory, it has to go in the binary form. So, C3 the opcode, of course, C code 1 1 0 0 and then 3 0 0 1 1 and 85. Okay. 1 0 0 0 and then 5 0 1 0 1 and 2 0 0 0 1 0 0 0 0 0. Okay. So, this is the first byte, second byte and third byte, first byte, second byte and third byte. So, this instruction what is there inside the memory, what goes actually inside the memory in the binary form, it will be this one byte, then another byte and another byte. Okay. This is the final thing which the microprocessor will take, and then it will decode and perform this jump operation. So, the first byte, second byte and third byte. Now, let us see about the addressing modes of 8085. Okay. So, you have to, there are various methods of, you have to specify the operand which you will be using in your program. Okay. So, you want to perform a arithmetic or any operation, you have operand. So, there are various methods of addressing the operand or calling the operand, specifying the operand. So, they are called as addressing modes. Okay. So, what are the different addressing modes of 8085? So, we have register addressing, immediate addressing, memory addressing, then input output addressing. So, we will now see one by one these various addressing modes. First, we will see about the register addressing. So, in this case the operand is there inside the internal register. Okay. So, you want to move a number to the accumulator. Okay. The number that has to be moved to the accumulator is inside this register B. Okay. So, you are addressing the number. So, you are addressing the register. So, by addressing this register means you are taking the number that is inside the binary bit, that is 8 bits, okay, inside this B, and then putting it in A. Okay. Then say another instruction, another example, add C. So, you want to add something to the contents of the accumulator. Okay. So, now you are taking the contents of the register C and then adding to register A. You are addressing the data that is there in the register, that is already there in the register. So, this is called as register addressing. You are addressing the register and the data is already there in the register, and then the operation is, say, the addition operation is done. Okay. So, this is called as register addressing. Okay. Then suppose if the data is not inside the register, then you can also, along with the operation code, you can mention the data. Okay. So, you want to move a binary digit represented by 20H to the register A, that is to the accumulator A. Then you can write the opcode for move immediate A, and then immediately following the opcode you can mention the data which you have to move to register A. Okay. So, you can also move 8 bits or 16 bit at a time. Okay. So, for example, you want to store some address or some 16 bit data, then also you can that also is possible. So, LXI X means extended means 16 bits. Okay. So, we can move immediate data, extended means 16 bit data to 2 registers. H means is not simply H. So, it represents H and L. So, because one register can hold only 8 bit data, okay, you require 2 registers to hold this 16 bit data. Okay. So, H means actually it is H and L. Okay. So, this 16 bit data will be moved to H and L. Okay. So, we tell the opcode for this, and this opcode is immediately followed by the data, the 16 bit data that has to be moved. Okay. Similarly, any arithmetic operation also, you want to add a number. Okay. So, you can give the opcode for adding a number, and then the number immediately follows the opcode. So, this is the immediate. So, you are addressing immediate. Okay. So, the opcode followed by the data, this is called as the immediate addressing. Okay. I means immediate. So, add immediate, subtract immediate, and so on. Okay. So, like that you can have immediate addressing. Okay. Then the address, so your data can also in the memory location. Okay. Your data can be in the register. So, you can mention the data immediately following your opcode. We saw the immediate addressing. Then your data to which you want to do some operation can also be in some memory location. So, this is the memory addressing. Okay. So, there are 2 kinds of memory addressing. Okay. One is the direct addressing and then indirect addressing. Okay. Direct addressing means you have to mention the location of the memory. Okay. In the instruction you have to mention the location of the memory. Okay. Then indirect addressing means you do not directly mention the location of the memory, you just point out the register. So, the 8085 register which contains the location of the memory. Okay. So, which already contains the memory address. So, that is the indirect addressing. So, we will see the direct addressing. So, in this case we have to mention the address of the memory location along with our instruction. Okay. So, you want to load a number that is stored in the some memory location, then you have to mention the address of the memory location. You want to, so you have stored a number, a binary bit, okay, in memory location 2050 H. Okay. So, you want to store it in the accumulator, then you have to mention load accumulator, and then immediately following this you have to mention the address, exact address where the data is present. Okay. So, load A with the contents of the memory location with address. So, from this address the contents will be taken and then it will be put in accumulator. Okay. Then store. So, suppose you have already some result in the accumulator and you want to store it in the memory location. Okay. Then you have to mention where you have to store the data that is there in the accumulator. So, you have to mention exactly where your data has to go. Okay. Store accumulator, okay. You have to mention the entire address. Of course, this is a 16 bit. Okay. So, you have to tell that, okay, store accumulator opcode and then followed by the 16 bit address. Okay. then the contents of the accumulator will be taken and then it will be stored in the memory location 3050H. Okay. Then another is indirect addressing. So, in indirect addressing, okay, so we preload the address of the memory location in a register. Okay. So, since in a register pair, okay, since the address requires 16 bits, so you require pair of registers. Okay. So, in this case H and L registers are used. Okay. So, the address where you want to load your data, okay, or take the data has to be preloaded. Okay. So, in register pair, so in this case H and L registers are used. Okay. So, previous case, so we mentioned the address 20550H in along with our instruction. So, in this case 2050H is preloaded by the move in normal move instruction. Okay. And then we simply say move m comma a. Okay. So, we do not mention any address here, we simply tell the opcode, that is move m comma a, that is just the opcode. Okay. Not a memory address is not mentioned here, but the memory address will be taken. So, the microprocessor will take the address from this HL register pair and then it will move the data from the accumulator to the memory location 50H. Okay. So, it will take the data from the accumulator and move to the memory location 2050H. Okay. So, this data is moved to this memory location. Okay. So, now we will see the what we have seen so far in this lecture. We will have a quick summary. So, we saw about the instruction sets. Okay. We saw about the branch instructions, conditional branch, unconditional, and then we also saw about the call and return instruction, again the conditional and unconditional. We also saw the addressing modes of the 8085. Okay. So, now let us let me ask you few questions for you to find the answer. Okay. First question is distinguish between jump and call instructions. Then the second question is mention the various addressing modes of 8085, and the third question is give 4 examples for direct addressing. Thank you.